Good morning, everyone. Sorry, it's good evening, actually. So, good evening, everyone, and I welcome you in today's second episode of Teachers Spotlight. Today, as you know, we are going to talk with Dr. Prajish Prasad, who has just finished his PhD from IIT Bombay in Educational Technology Department, and he worked on how students reason with software design diagrams. So we will know what was his research work, how he worked on it, and what was the outcome. And we will try to know how you can use his thesis work, his tools in your work. So before we continue, I will play this short AV to give you a little intro about Dr. Prajish Prasad, and then we will invite him and talk with him. During our conversation, you can write your messages in chat box. You can use live chat on YouTube, or you can also use Facebook comment box to send your questions to me. I will then ask these questions to Dr. Prajesh, and then he will answer us. And I believe we all are going to learn a lot by this. So let's play the AV for Dr. Prajesh.
Dr. Prajish Prasad just completed PhD from Educational Technology Department of IIT Bombay. He completed Masters of Technology from Computer Science Department of IIT Bombay. His B.Tech is also from Computer Science. He has worked in a company LoudCloud Systems as a software developer, but soon he realized that his interest is teaching and joined an engineering college as an assistant professor in information technology. While teaching students, he finds that students are struggling to understand principles. He decided to dig deeper into this problem and joined PhD program in Educational Technology Department of IIT Bombay. He was interested in understanding how students reason with software design diagrams. He draws inspiration from learning sciences, software engineering, and computing education literature for his research. As part of his thesis, he has developed a technology-enhanced learning environment Verisim, which helps learners reason with software design diagrams like class diagrams and sequence diagrams. In second episode of Educational Talk Show, Teachers Spotlight, we will talk with Dr. Prajish Prasad and know about his interest, his thesis and Verisim tool. You can join this live talk show on ET Mantra's YouTube channel on 6th July 2021, 7 p.m.
So I believe you like this AV, and now it's the time to invite Dr. Prajesh Prasad with us. So welcome, Dr. Prajesh,
Thanks, Yogi. Thanks for having me. Thank
and
you.
how are you?
Yeah, I'm doing good. I'm doing good.
This is Corona time. People are struggling to do normal things, and you have completed your PhD during this time. So how are
Yeah,
you feeling now?
yeah. I'm very thankful actually that there have been challenges, but yeah, by God's grace, I could complete my PhD. I'm feeling much relieved now. Yes.
So can you introduce yourself so people know who you are and what you do? Then we will start our conversation with
Sure, sure. So, hi, I'm Prajish Prasad. I completed my PhD in Educational Technology from IIT Bombay, and before that, my bachelor's and masters are also in computer science. And after my master's degree, I joined as a software developer in an edtech startup, LoudCloud Systems. And after working for 1.5 years, I switched to teaching and I joined as an engineering instructor where I taught various courses like Java programming, network security, and so on. And after that, I decided to plunge into research and specifically education research. And 6 years ago, I joined the Education Technology Department at IIT Bombay. And yeah, it has been a great 6 years where I delved into research and teaching and learning and many other things, and got to build a lot of tools and also conduct studies with students. And yeah, that's my journey. And now I've just completed my PhD.
Great to listen about it. Um, so one question that comes to, I believe, everyone's mind. You graduated from a very good college. At least MTech is from IIT Bombay, correct? So then people generally go for industry. But you are the one who left the industry, joined a college, and then you joined a PhD program. So what was the reason behind it? What was the motivation behind it?
Yeah, so right after my MTech, I joined an education technology startup, LoudCloud Systems. So, and I had a lot of fun there. It was I was a software developer. I was working on uh, building and enhancing their learning management system. So I worked on frameworks in Java like Spring, Hibernate, and then I worked on the front end also. And all of this was all of this was I was very excited, uh, to work in these technologies, and uh, but my passion and my interest was in teaching, and I like to be with students. I like to interact with them, mentor them, and down the line I felt, I could be more of use, and use my skills in teaching better. So that's why I decided after 1.5 years to switch to teaching. And yeah, it's an unconventional choice. uh, yeah, but I think it was the right choice at that time.
Yes, yes, now we can say it, and especially when I know about your work, I can definitely say it. A lot of people are going to take benefit from your thesis. And those who are joining us and from computer science background, please be here with us till the end because you are going to get very good insights, very good pedagogical related information about software design diagrams. So that's really great to know about your journey from switching from a job industry to college and then. So what was the how your family reacted to that?
Yeah, I would say my family has been very supportive of all my decisions uh, at every stage, right from engineering, then masters, and even my job, the decisions which I made in my job. So it was unconventional, yes, but uh, I feel, if you can clearly articulate and clearly tell, why you're doing certain things, uh, uh, and I think if your family, definitely, later on your family will also understand the reasons behind it. So, uh, yeah, I think you should always do things which you are interested in which you feel you can make a difference, in which you feel you can serve others better. And for me, it was not difficult convincing my family, but I think for many others it can be. Uh, but I think, yeah, I think you have to stay true to yourself and move ahead.
Yeah, yeah, great, great. So can you tell us something about your thesis now? Because that's what most of the people are waiting for. So what's there for teachers? What's there for students? What is exactly there, and how you take that path? Everything that you can tell about your thesis.
Yeah, so I joined the PhD after, my experiences in the software industry as a software developer, then as a teacher, and I think both of those experiences were very useful for me, because I got different perspectives. As a software developer, what is used in the industry, what is important in the industry, uh, and then when I switched roles and became a teacher, I saw, what is being taught. I saw where students are struggling, and I understood this gap between what is there and what is required in the industry and what is taught. So, uh, so I think the main ideas or the key things in my research have come from these experiences. So, for example, when I joined the software industry, uh, before that, I used to write small programs. I used to build small projects, right? But when you enter the software industry as a developer, you have to work in huge projects, right, which have thousands of lines of code which you have not written. So many others have contributed to it, and you have to uh, work on a small part. Maybe you have to fix some bugs, or maybe you have to add a new feature. Yeah, adding a new feature is not easy, because you have to understand the whole system, right? You have to understand the different parts of the system, how it behaves, and if you change something, will it affect other parts of the system? So all of this, I found it difficult, and I realized that is not taught, in software engineering courses, especially. And that's what I found in uh, when I was teaching also. Especially students struggled to uh, understand code. Even if I would give them program a simple program, they would have difficulties in understanding what it does, what is the meaning of this program. And sometimes it's very disheartening to see students, they learn code by heart, or they learn it by rote,
Mm.
and then reproduce it in the exam, right? And so basically I wanted students to help students reason with a given program or a given design. And that is at the heart of my PhD thesis and my tool, Verisim, where I want to help learners reason with software designs. So, for software design, there are different diagrams. It's like a blueprint of the entire software system, right? When you want to build a building, before that you actually, create a blueprint, which is the design. Similarly, in software also, you have the blueprint, which is usually represented by different diagrams called these UML diagrams. So, uh, and what uh, what I saw from I conducted some studies with students, and I read many papers. And what I found is that students have difficulty in making sense of all of these different parts, these different diagrams. How are they related to each other? What is their purpose? Is it really required to create all of these designs? Why can't we just directly jump into coding? So all of these difficulties students had. So through this tool, through the Verisim tool, I am presenting learners with a pedagogy called design tracing, which will help them make sense of these design diagrams and help them develop an integrated understanding of these design diagrams.
Okay. So I understand your point that yeah, students struggle a lot and they actually go for the rote learning methods. So, but what is the solution to that? So let us say if we come to this other subjects, for example, physics or mathematics, then some kind of discussion with them, maybe collaboration among them, and maybe let them experience something is helpful. In physics, you can do a lot of experiments. But when it comes to programming, what is the solution to this? So it's a little difficult to understand. And then when you are moving to software development, in software development, especially when they are not actually developing a software, they cannot develop software. while they are learning basic things like programming, computer networks, and other subjects. At that time, how you think means how your tool can actually let them think about the big system and how they can move from rote learning to actually involving into the designing or taking decisions. So what is there actually? I am unable to find the connection that without actually developing something, how they are going to learn it.
Yeah, that's true. That's definitely true. So, um, uh, one is definitely, doing a lot of projects, doing a lot of coding, that will definitely help. But apart from, the main concepts in programming, you know, what learners need to understand is, there are certain practices or skills which experts use or experienced software designers use, right? And definitely what they learn in classrooms, that might not be used in the industry directly, right? So for example, personally for me, I learned C, Java in my B.Tech days, and now the world has moved to other uh, programming languages like JavaScript and Node and all of that. But uh, what is essential to teach students is these underlying strategies or underlying skills. It's not about, yes, you have to understand the concepts, but it is not so much about the syntax, or the key, or for example, for UML diagrams, for design diagrams, it's not more about how, like, what are the different notations or what are the different syntax and all of that, but it is more about uh, helping them think about how to model a given system, or giving them teaching them certain reasoning strategies which experts use, which experienced developers use. So I think all of that is also very important along with the concepts which we teach, and hopefully they will take that to the industry, and with experience, they can do well.
So how your tool is helping, and can we have a look of that tool if that tool is available for everybody to use? So if that's possible, that will be really good.
Sure, definitely. Yeah, I can give a demo of the learning environment. So is my screen visible?
Yes, yes, yes. Your screen is visible.
Okay. So this is a learning environment I developed, Verisim. Uh, so it's freely available online. You can search on Google for Verisim learning environment, or this is the URL, verisim.tech. Yeah. So the key strategy in Verisim is the design tracing strategy or the pedagogy. Uh, yeah. So, as a user, as a student or an instructor, you can uh, register into the system. Let's say you give a username and password. Yeah, once you register, then um, uh, the system explains, what all you will be doing. It gives a brief overview, and then it puts you as a software developer who has just graduated, and you have been placed, and you are starting as a software developer, and they go through a video which which explains, like, yeah, you have entered this company, and uh, you are introduced to your project manager Neha, who will be your team lead, and she introduces you to the team. So there is a senior software developer, and then there is a software developer. So the point of this video is to help students understand what does a software development team look like. So the team leader explains, the first step in designing is designing of the software. Like you have the requirements and the design, which is represented as UML diagrams, and this is passed to the software development team. So it is very important that the design actually maps to the requirements and it is correct, because if there are errors in the design, that is sent to the development team, and the development team will design it based on the design diagrams given, right? And then the software development team develops the software and uh, gives it to the software testing team. Yeah, the code is tested by the testing team. So this video gives an overview of what happens in a software team. And after this video, learners can click on the next button. Yeah, and then they are taken to a dashboard. Now this dashboard contains three stages: the problem understanding stage, the design tracing stage, and the reflection stage. And in each stage, there are different challenges. The challenges are on the right here. And as learners complete challenges, they acquire certain skills. So we have used a sort of a gamified approach where there are different challenges, there are different stages, there are points which they can gain, they have a score in the end, all of that. So the first challenge is they have to understand the client and their requirements, which is usually the first stage in the software development process. So when I click on start, the learner is presented with the context of, last month we got a contract from Safe Home Technologies to implement the software for an automated door locking system. Okay, and then the team leader tells that the software design team has collected the requirements from various stakeholders, and they have created the UML diagrams. Now your responsibility is to see that this is correct, right? Yeah. So the first step is to look at the requirements. So, for example, in this case, we see that there are three requirements are presented to the learners. So, for example, one can register oneself. Second, what will happen when the user chooses a lock option? When he enters the correct passcode, when he enters the incorrect passcode, what should happen? Similarly, for the unlock option. So once learners go through these requirements, then they have to answer certain questions. So these are evaluation questions which test their basic understanding of the requirements. So they can go through the requirements at any time, uh, read the questions, answer them. So for example, I'm just answering them randomly. And when they click on submit, they get feedback for both the correct as well as the incorrect answers. Okay. So once learners have understood what the requirements are, then in challenge 2, they now understand what are the different design diagrams. So this is known as the agent. So this a pedagogical agent uh, gives certain steps or gives certain prompts or details about how the interface looks like. So this space is known as the design diagram space, where it tells that this diagram is a class diagram. These are different sequence diagrams which describe the behavior of the system. So what is the behavior for lock? What are the different messages which are passed? For register, what are the different messages? So this is called as a class diagram, which describes the structure of the system, right? What are the different modules? So you can have a user, you can have a passcode, behaviors for, and behaviors of each of this are mentioned as functions, and specific behaviors like what will happen when you lock a door. What are the messages which are passed between different components. All of that is explained. So as a learner, I go through, the system also describes, gives a brief overview of these diagrams. And after this, uh, I answer a reflection question which asks me to identify defects in the design based on the requirements. So the purpose of this activity is to help learners carefully analyze the design diagrams, look if there are any defects or if there are certain things missing in the design. So I'm just mentioning some test data here. Then similar to the uh, previous challenge, you have certain questions which are based on the design now. So for example, what are the possible return values of check passcode? So the learner has to uh, look at the class diagram and see where check passcode is. So we see that check passcode is a function which returns bool, and bool is nothing but true and false. Yeah. So similarly, they uh, look at, answer the other questions. They get feedback. And the third challenge, in the third challenge, the learner is made to understand what scenarios are. So, what is actually a scenario? It is nothing but a possible execution of the system. So, what we found in literature also is that when experienced software developers, when they look at these diagrams, when they look at the design, they are not thinking about, these are not just pictures or images or diagrams for them, but in their mind, they create some model of the system, and in that model, they are, thinking of how the system will behave when this scenario happens, or when this condition is satisfied, what actually happens in the system. Suppose if the set option is called, what values change, or how does it affect other parts of the system. So experienced designers are able to think like that. They're able to understand the relationship between these different diagrams. So the first thing which learners have to do is to think of multiple scenarios in this given design. So, for example, this is a scenario when the door is initially unlocked and the user chooses the lock option and enters the correct passcode, the door locks. So, after they go through this scenario, then the system asks them to think of multiple scenarios in the design. So, again, they can look at the design diagrams and think of multiple scenarios and write them down here. And similar to the other challenges, then the system asks them other questions like what is an invalid scenario, or the system asks them to complete this given scenario. So by this, learners are made to think and reflect on different scenarios in the design. So after they do this, uh, a message comes saying that the design tracing stage has been unlocked. So that is the second stage. And in this stage, there are four challenges. So the first challenge is they have to explore a model. Second is they have to correct an incorrect model. Third is they have to complete the model. And finally, they have to construct the model. So what is this model? We will look at that. So when the learner attempts the first challenge, we see that the interface is similar. You have the class diagrams, you have the sequence diagrams, but you see another representation here. So this is nothing but a state diagram. So it has states, which are these circles, and these arrows are called as the transitions. So you can see for each scenario, the learner can create a state diagram. So for in this case, you can see that the transitions, they correspond to parts of the scenario. So for example, the first thing is the user chooses the lock option. So when the option is set to lock, something happens. And when they enter the correct passcode, which is this, something happens. And then the door locks, right? And what are these things inside the state diagram? Inside the states are nothing but values from the class diagram and the variables from the class diagram and their corresponding values. So for example, when you set the option to lock, the value of option selected changes from null to lock. Yeah. So another important feature of the learning environment is this run button. So when you click on the run button, you see that a part of the scenario is highlighted, the corresponding state diagram is highlighted, right? And when you click on run, the second state is highlighted, and we see that the corresponding messages in the sequence diagram is also highlighted. And here you can see that values of the variables uh, in the class diagram also change, right? So with the help of this visualization, learners are able to understand the relationship between the different design diagrams. So if something changes here, what is actually happening in the class diagram? And when a scenario executes, what are the different behaviors, or what are the changes happening in different diagrams? So Verisim is helping learners understand that, right? So after they go through this challenge, similarly they answer certain reflection questions, which are based on what is a class diagram, what is a sequence diagram, and what is a state diagram. So they have finished challenge one, and then they go to the second challenge, which is correct the model. So here we can see the interface is similar, right? And we see that the state diagram is also given, but it contains certain errors. So the objective in this challenge is to correct this state diagram, which is incorrect. So the learner can click on the run button at any time. So for example, when I click here, I see the agent gives a feedback saying that there is an error in the highlighted state. So I realize the learner realizes that there is some error in this state. So they can go to the edit button and click on the appropriate state. So in this case, it is the initial state. So, and then they look at the scenario and see, okay, the door is initially locked, whereas the value of lock here is false. It should be changed to true. Right? Similarly, the learners can edit the other states also at any time, or they can click on the run button at any time to get feedback. So for example, here you see that I have corrected the state. I can, when I click on run the second time, then I realize, okay, there is some error in this state. So the learner continues doing this until they have uh, correctly modeled the entire scenario. So yeah, I won't go into the details. So in the third challenge, they have to complete an incomplete model. So here you can see that none of the state states are empty. So you have to add relevant data variables. So you have to choose from which class, what is the variable and what is the initial value. And then you can see that value is added to your model. Yeah, that is added to the model. And similar to the other challenges, the learner can click run on run at any time and get feedback and continue this process until they have correctly modeled the scenario. And finally, they have to construct the model. So in this case, you see that nothing is given, the events, the states, nothing is provided, and they have to build the entire model from scratch. So, what are we training learners to do in each of these challenges is to help them understand the relationship between these different diagrams. So, we believe that as they construct this representation, this state diagram, they are able to understand the relationship between different diagrams, and they are also able to imagine in their mind how this scenario is executing, which helps them understand different scenarios in the design, and in general it helps them understand the entire design in general. So how does this help them in the industry when they graduate or in their software design courses? So uh, what, what we saw from studies with students is also that they are able to now, if they want to create a software design, they can think about what are the relationship between these different diagrams, and they can use this strategy when they create designs also. Yeah, i I hope that was helpful.
Yeah. Yes, yes. Actually, it was really good because I'm surprised to see. First of all, I have seen your tool for the first time. I have never get the chance to see it. So I saw it for the first time here in this show only. So I have few questions, and first of all, I like your tool a lot because I see that there are so many principles you have followed. Like you provided scaffolding in first stage, then you slowly remove the scaffolds, and at the end, the student has to design everything on his own. Still, I believe the system is giving the feedback.
Yes.
That is one thing. Second, this scenario that the question that I was asking in the beginning, that like for the physics you can show them an experiment and they will be able to visualize that and they will understand the principles behind a particular concept. In programming also you can, let us say, give an example. They can show the data flow and other things and then they will be able to see it. But in this particular subject, software development, software design, unless you are in the scenario, you are leading the software, you are managing the software, you don't actually know what to do.
Yes.
Correct? It's very difficult to visualize. It's very difficult to understand the position of a software manager.
Correct.
Correct. But you did that using your tool. So you actually put a student in the scenario. So there he is given a task and he knows that he has to handle these things. And there also you provided scaffolds, feedback, a lot of activities are there. So really good to see your tool, and I believe a lot of teachers will find this tool useful to teach the software design diagrams, especially. But I believe the whole software development related concepts are being handled here, not just the diagrams. Diagramming is just one part of it that I can see. Now
Yes.
I want to know if it is possible to change the scenarios in your tool. If I want to create my own scenario in your tool, is it possible?
Yeah, so right now it is not, because I have created this only for the scenario of the door locking system. But I believe, and I also want to, extend this research and extend the development to, create an instructor interface where instructors can come up with their own scenario or their own context. So if I want to create, for example, a library management system, uh,
Yes.
So for I think it will be a very good addition to add an instructor interface in Verisim, and yeah, that is actually in my mind, and it's part of the future work. I hope I can do something like that. So then I think it will be very useful for other instructors to add their own scenarios and yeah, provide practice to students.
Because then what will start happening? Teachers, because there can be a lab related to software development or software systems, so they can then add their own exercises there.
Right.
So, so some model related to that, and then a student will navigate through that. So this way, what will happen in few days? A student will be attempting not only one scenario, but let us say seven scenario, nine scenario based on this syllabus. And in that case, this tool is going to be really useful for all of them. The second thing that I want to know, uh, if this type of thing, like your thesis worked on computer science, and in computer science you worked on software development, and that also you picked that particular diagramming things, class diagram. What do you think, if your software is this very same tool, can it be extended to support other subjects where diagrams are required? For example, chemistry, biology, some medical related fields, um, where diagrams are the important thing. What do you think? Is it possible some way to modify, or at least the principles that you have worked on? Is it
Yes.
suitable?
Yeah, so in my thesis, the main idea is model-based learning, and that is taken from science education literature. So in science education, as you mentioned, right, like when students want to visualize a scientific phenomenon, for example, they want to understand how photosynthesis works, for example, they can create a model, right? Maybe a physical model, maybe a computer simulation, and then they, modify or revise that model until it correctly maps to the scientific phenomenon. And and model-based learning has been widely used in science education, and it has and the results are also well established. So the the key idea of design tracing and the activities in Verisim is derived from model-based learning in science education. So definitely, I believe since we have borrowed all this from science education, we can definitely take all this back and use it in, especially for learning of science concepts. Uh, for example, uh, like in this case we have created a state diagram, that is our model, but for a science teacher, for a biology teacher, or for a physics teacher, their models will be different, right? And
Yes.
this order of scaffolding, like first they explore the model, and then they complete and correct, and finally they construct the model. This has also been taken from science education literature. So this order of activities also can be provided to students to help them construct a model in the end, because literature has shown that at if you tell students to construct a model from scratch at the start, they find it very difficult, very overwhelming. So but if you scaffold them to uh, first maybe change the model a bit, or uh, or fix some errors in the model, then they develop an understanding of what to do, and then they are able to do it in the end.
No, guys. So basically, anywhere where model-based education, the correct term?
Yeah.
Okay.
Yes.
So where model-based education is used, I believe your type of tool can be used, but definitely either your tool need to support various models, or a new tool with new models needs to be constructed.
Yes.
Correct. So because I know that tool development is not an easy task. So now I want to know about the this tool creation, how it is developed, who developed it, how much time it takes to develop this tool. So let's answer this question first. How much time it takes to create this software? Verisim.tech.
Yeah. So, uh, yeah, the first thing is I just designed the pedagogy and the tool, the design, I mean, the look and the feel, the UI has been developed by Kinnari, and the entire software development has been done by Bhupender. So both of them were project interns in our lab. So this took around, and there were several iterations. So we came up with the initial prototype, then you know we did some studies, some pilot studies with students, then changed it, redesigned it. So this took some time. I would say this took around 8 to 9 months. Yeah,
Oh, still it's a good time because I have seen tools developing in 2 years, 3 years in PhD.
yeah, yeah.
So now let us say if someone else, so there are many teachers joining here. Some are from chemistry, some are from biology, some are from various fields where model-based education can be useful. So if they have to develop your tool, what help they can take from you?
Right. So definitely, if you want any advice on the pedagogy or what should be the type of activities, uh, definitely, I think you can look at literature from model based learning. And in my papers, also, I have cited those papers. You can have a look. And the other thing is, uh, especially for science education, I think there are a lot of tools which actually do this, which there are a lot of modeling tools in science education. Uh, so what is more important is how you can use these tools to and bring them into your teaching and learning, into your teaching. Like for example, in classrooms you can tell students to play with this tool, create some model, then you ask them some questions or you give them some activities. So I would say that developing an entire tool from scratch, that is difficult, and you need help from, you need a developer, you need a designer, all of that. So for me, I couldn't find such tools for software engineering, for software design. That is why I had to create it. But definitely, I believe that if you have some, there are tools available, and if you can repurpose that and add some questions or add some Google Forms, for example, that uh, that would be better, maybe better than actually building the entire system from scratch.
But if you look from my point of view, I am a tool lover, you can say. I keep exploring softwares, tools for teaching. I'll say that your tool is really good if few things can be done. The first thing that I think is the flexibility to add new scenarios.
Right.
And that should be added via JSON rather than coding. That's the most important requirement. Because I see there are possibility of giving feedback, there are possibility of telling scenarios, the possibility of removing, adding scaffolding, adding stages also, because in your case there are 4 stages, but in somebody else's case there can be multiple stages. So I can't think a flexible way other than the JSON or a NoSQL database. So JSON is something that is going to be really useful here. And then if that is happening, additionally, if this tool can be integrated inside Moodle
Okay.
or EDX, Open EDX, then it's going to be really used by people, because then they don't have to search for some other website. Everything will happen within one roof. So the student will log in only one place and then they will find this software. So if that is possible, I will say that you should go with this, because while you are explaining your software, na, I was thinking if I have to implement the software, can I use H5P for that? like you said, that like using Google Form and other things, it can be done. But even if I use H5P, which has a lot of JavaScript related functionality which is required in this case, still I will not be able to do in one activity. I will be able to do it, but I have to create multiple activities for it.
right.
In one activity, I cannot. And the challenge is that you have to pass information from one activity to another activity.
Yes,
Students' behavior with your tool, you have to pass it, and which is again a difficult task. So going through your tool will be much better. Maybe we can contact Bhupendra and Kinnari to make this tool for other teachers and for other subjects also. Okay,
yes.
so what technologies are used in, if you know about it, to create this tool?
Yeah, so
What's the tech
this,
stack?
yeah, the tech stack is uh, the front end is Vue.js, Vue.js, then Node and uh, MongoDB is being used.
So basically, again, a no SQL databases.
No SQL database. Yes, yes,
And what was the language for? Okay, Vue.js is used for interactivity also.
yes,
Okay,
yes,
so I see there is no business logic other than Vue.js.
yes, yes,
Vue.js is handling everything, and Node is the server, and finally database is MongoDB. So
yes.
I believe if we look at the database, then maybe creating new scenarios will become little easier.
Yes, yes, definitely. I think Bhupender has created it in such a way that it is modular and there are different components. And I definitely feel you can extend it. Yes, there won't be difficulties in extending it. Yes.
So we have received few questions, few comments, few feedback from people. So one, Sir Manohar Chaudhary sir wants to know your email address. He want to contact you for something. So if you would like, so he has said that please share email of Prajish sir. If you want, you can.
Sure, sure. Yeah, it's there on my website also. So you can contact me anytime. Yeah. Or I can
So
say
if
it's
you,
Prajish
yes,
dot
yes, please say.
yeah, prajish.prasad@gmail.com.
Okay. So I am showing Prajish sir's email address, and you can contact him on that email address. It's prajish.prasad@gmail.com. So here, Jatin has said that it looks to be nicely useful tool designed by Dr. Prajish. And Muhammad Az sir has said that nice Prajish sir, it's look good and easily understanding for beginners. So that is definitely true. Given that lots and lots of teachers start using it. There's a question by Pharmacy Vidya ma'am. She's our regular viewer, and she wants to know, sir, is it only for computer science field? And
Yeah, I
you
think we
want
answered
to,
that. Yeah. So, especially for a PhD, right, you need to scope the topic and the field such that, so it's not, uh, so there are a lot of tools which can be used for, variety of domains and all, but especially Verisim, as I mentioned, it is applicable in the current form. It is applicable only for software design. Yeah, but I believe the principles can be, extended to other other subjects also.
yeah. So basically, if it's model based learning, if your subject supports model based learning, then the same kind of thing you can use. But I believe even without the tool, it can be used. Means, let us say if this tool is not available, Verisim is not available, how do you suggest to do that? Because see, at the end, unless they create a model, they create a scenario, they'll not be able to implement it in a software. So you have any suggestion for that?
So uh, the question is, how can they create such tools for their context?
No, 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 no. For example, I don't have Verisim. Let us say Verisim is just launched, correct? So let us say Verisim is not there, but still model based learning is available,
Yes,
correct?
yes,
And I want to do this thing somehow manually,
right,
because
right.
before we reach to a tool, we have to give some activities. So how do you suggest to do it and manage it in a class of, let us say, 30, 60 students?
Right, right. Yeah, so I think creating models is so important in many fields, and one way can be to divide students into different groups, give them the scenario, tell them to create a model. They collaboratively think about it, come up with some representation, and then maybe they can present it in the class, and teachers can uh, others can give feedback on that. So the whole idea of there is something in your mind, and you want to bring it out, you want to externalize it as a representation. That idea is very powerful, and it has been shown to be effective. So giving students opportunities to bring out their reasoning in the form of some representation, I think that is a very useful strategy. They can do it collaboratively, individually, using some softwares. Yeah, so those are some strategies I think teachers can use.
Really good to know about the Verisim, about your thesis, and about the model-based learning, especially because that is something that can be replicated other on other subjects as well. So now I want to know some moments, memorable moments from your PhD journey, or from IIT, or from hostel, whatever you pick. It's up to you. Any memorable moment.
Yeah, so there have been lot of moments, memorable moments, but I think the the okay, I'll give you multiple. So one is, how do you understand what to build, what is the problem you want to work on, right? So I think in the PhD process, one of the most important or difficult things is to understand what is the problem you want to solve, and coming to this problem of students find it difficult to understand the design diagrams, or they just look at the design diagrams, they don't go deep into the meaning or the behavior of the design. So uh, that moment, that understanding came from certain studies which we conducted with students, and that was like an aha moment. Oh, okay, this is the difficulty which students have. Okay, then we can build something, some tool or some pedagogy can help them address this difficulty. That was a that was a memorable moment. And then I think throughout the design and development, it was a very uh, fun journey, because as I said, I was working with Bhupender, Kinnari, other members of my lab. Uh, it had a feel of the software development industry. You are prototyping, you are iteratively changing things, you are fixing bugs. So I enjoyed that process also. And finally, I think my first study, which I conducted with students using Verisim, and the feedback which I got, and actually going and conducting that study, I think that was also a great experience.
Good, good. So yes, again we are receiving the same question, which we have discussed for almost 10 to 15 minutes. So the question is by I'm unable to read the name of the person. It's Foodie Goody. Okay, most welcome, sir, ma'am. So you have asked that, uh, Prajish sir, I want to ask question: can Verisim is used in other domains other than computer science? So shall I answer it this time, and you tell me
Sure,
whether I am right or wrong?
sure, sure. Go ahead.
So, if you are asking whether it is used, no, it is used only for computer science till date. And if you want to know whether you can use it in another domain, then I will say as of now, no. But yes, new provisions are coming. Maybe one day you will be able to create your own scenario in the tool, and then you will be able to do it. But during this conversation only, and especially after looking to your question, I come to a solution to this problem, and that is going to work for sure. Okay,
Okay.
what you need to do, you need, so in the whole Verisim tool, what I found that implementing may be little easier. Canary is here, so she may she may say that you are not listening to us properly. But I am saying that, okay, thinking about the scenarios. is one thing, because you need to know what feedback you want to give at what problem. Correct. You want to know where to scaffold, where you do not scaffold. So before things implement, you have to design the whole scenario and everything. And
Yes.
whatever Prajeet has shown in Verisim, exactly the same thing can be created using PowerPoint if your scenario is fixed, because PowerPoint gives you all the tools, like you can click, you can make available the so if somebody clicks on at a particular button, they can jump to a particular slide. So this is possible in slideshow, but you have to be very careful in designing how to design that, at what answer you want, what feedback. And I think that is already been done using MongoDB here, MongoDB and Vue.js. You can do the same thing using text and PowerPoint. So you
Yes.
first try to do that with PowerPoint, then share it with us. We will see that what you have created, and if that is useful in your subject or not. Yeah, you will judge it in a much better way. And then we will see that what type of flexibility is required. If we start getting this type of models from various teachers, then we will be able to find out that what exactly we need to do to bring the flexibility in Verisim. And then it will be really, really good to see. So I believe you are satisfied with my answer. So
Yes.
Kinnari is here and she has said that great work, Dr. Prajesh.
Yeah, it's
And
I believe it's the efforts of so many people. Yeah, my supervisor, Dr. Sridhar, is also here.
yes,
Kinnari
that is
and
also here.
Bhupender and all my friends and colleagues. Yeah. Yes.
Okay, so that was about your. Again, you missed the fun part. Actually, I wanted to know. I wanted to listen about a particular event, which is apart from the academic and from your research, your IIT Bombay's life. But you bring back to that when you were interacting with the students and all. So, if you
Yeah.
can tell us a moment that is really memorable to you, apart from academics and your research work.
There are many actually. I think one fun part of the PhD process is going for conferences together, and we have gone together for T4E, and with my colleagues, I could go to some international conferences also. So and that is a place where we are you know in a different context. You can enjoy, and we can spend time, we get to know each other much better. uh, yeah, specific instances are not coming to mind right now. Yeah, but I believe all of these travels, these interactions, all of that was fun. Yes.
So I'll now ask two more questions and then we will close the session. So the first question that I want to know, since the pandemic started, general people come to know about educational technology, but we for sure know about it from a long period of time. So if you have to define educational technology, how will you define it?
Yeah, so educational technology is uh, one, well, what I believe is it is not only technology or tools which can improve education, but it is more than that. It is about uh, a lot of things about what is the pedagogy, what is the underlying pedagogy, or uh, what are different strategies which you can use. So education technology is not only about tools, but there are so many other things, right? It's about the context, it is about understanding the learner. So you can have a very fancy technology, but if your learners are not motivated, or if the school or the college infrastructure does not support that technology, then what is the use, right? So uh, so I believe education technology is much more than just the tool. It involves understanding the learner, understanding the context, and only if you understand the problem and the context and uh, the learner, only then will you be able to design education technology tools and interventions. So maybe as a teacher, you might be thinking that, I don't know how to build such cool technology and tools. But I think the philosophy of our department is also that a good pedagogy is always better than, a very high end technology. And uh, I think education technology, the key thing is to understand learners and design pedagogies for them.
Yeah. Thank you for giving the definition or defining the whole system of educational technology actually. The last question that I want to know that what will you suggest and whether will you suggest people, the one who want to do research, those who want to do the masters, to join educational technology from their branches. Somebody is from computer science, somebody is from civil, somebody has done B.Ed, somebody is from masters, MA, MSc, like peoples. What will you suggest? Or let us say somebody has done law. What will you suggest and why will you suggest to join educational technology?
Yeah. So I would say the main reason is if you are deeply passionate about teaching, about learning in general, if you want to understand how people learn or how I can make a difference, uh, there are a lot of opportunities for both masters as well as PhD students, especially with the pandemic. Many, especially in India, many have come to realize the importance of edtech. So I would say, uh, visit our department's webpage, have a look at the type of work we are doing, see where you can fit in, and we also conduct workshops and uh, uh, many other seminars and all of that. So explore all of that and uh, see how, you know whether it is whether you want to take the plunge. So I would say try exploring the field, maybe read some papers, see the projects, and if you feel that you can make a difference and you're really interested in this field, then I would say you can join the MTech or the PhD program.
Thanks. So there's a question by Kinnari. She wants to know in the context of this pandemic.
Yeah.
She wants to know about your journey, challenges, and perks of doing PhD or MTech in the IDPET at IIT during this pandemic.
Yeah, the pandemic has been a challenge for all of us, right? But I think for me, especially for me, it was not so bad, mainly because I had completed all the development work, the studies with students. So I was in the writing phase when the pandemic struck, and my family also was very supportive, and so all that uh, because of all that I could finish my PhD. But I know many of my juniors and colleagues and all, uh, it was difficult. But then the other advantage is, um now you have a context, the online context, and you can, and some of my friends have also repurposed their problem and their tool, their solution for the online context. And uh, so many have adapted their PhD or the MTech problem to the online setting because of the pandemic. And yeah, other than that, as a lab, as a department, we have always tried to uh, be in touch and attend talks together. And yeah, so I think in that way, the department and people in the lab, we have tried to be together at this difficult time.
Okay, thank you, Prajish, for answering all the questions and telling about your journey, your experience of PhD, about your tool, about your thesis in a calm manner for which you are known. And you are famous for one-liners. So do you have a line for this particular conversation that we are having right now?
You're putting me at a spot, Yogi. I
Yeah,
cannot,
yeah,
I cannot come up with one-liners like that. Yeah, but I would say it was a great experience. Thank you for having me. This is the first time I'm doing something like this. Uh, yeah, thank you so much.
yeah. Thank you, Prajesh, for joining and giving us all the information related to your work, your tool especially, and I believe a lot of teacher will find that tool useful and will start using it. If they will not be able to use Verisym, at least they will try to do this in some other manner, and now they will search for this model-based learning especially. So thank you, Prajesh, for joining us. And now I'll like to say goodbye to you, and then I'll talk to my viewers and then close the session. Thank you very much, Prajesh.
Sure. Thank you, Yogi. Take care.
Thank you. Bye. So today you listen to Dr. Prajesh Prasad, who explained everything about his thesis, about the work that he has done in computer science education, especially about his tool Verisim. And what is more important than Verisim? The important thing is to know about that this type of environments, like putting a student into a scenario, is more important, especially for subject like this software engineer, where you they cannot experience it. But you are with the help of tool, with the help of technology, you can actually create a scenario where they can interact and know whether they are going in the right direction or going in the wrong direction. So thank you for joining everyone. Today the number of participants were really high than the first talk show. And now in the next talk show, we are going to talk with Dr. Chanda Jain. She's an assistant professor and she has done a lot of work in mind mapping. She has written a lot of books for NCERT where she has explained the concept using mind map. And mind map is a really great tool and it is useful for everyone, irrespective of subject you are teaching. Mind map is a really helpful tool. So that usually we conduct these teachers spotlight on Tuesday, but again I'm little bit busy next week, so I will do this in Tuesday or in Monday late night. But Tuesday, if I am going to do it, then we will do it in the morning. I have to take permission from Dr. Chanda Jain, but you will definitely love this because it's all about mind mapping. She has done a tremendous job. More than I think 1 lakh copies of his books, her books has been sold till now. And that's really huge, especially when it comes to mind mapping. So we'll talk to her in the next episode of Teachers Spotlight. I believe you will be with us in the next episode like you were with us today. Thank you very much and thanks for joining.